Maupay nga adlaw, ako hu iyo teacher Harold. Tututdoan ta kamo inaano paggraphhin polynomial function. Waray problema kung linear function tigpapagrafa imo because you can use several methods para ka makagraphhin linear function. Tapos kung quadratic function, waray gihapon problema. Magamit ka lahan vertex or bibilngon mo lang niya vertex and direction of opening and y-intercept tapos ang iya mga roots or x-intercepts or danay kasi excuse me, danay kasi inin waray x-intercept ito sa nga ito sa nga quadratic function, pero definitely may dagod hiya roots, may dagod hiya inin mga solutions, sometimes imaginary. Pero diri ito problema, basta may dakala vertex, direction of opening, tapos ang iya y-intercept, i-connect mo ito using smooth curve, makakahimo ka na hiton graphite quadratic function. Ang problema kung higher degree polynomial such as cubics, quartics, and so on. So yan na, tututuan ta kamo inaano paggraphhin usa nga polynomial nga inusa nga quartic polynomial. P of x is equal to x raised to 4 plus 3x cubed minus 3x squared minus 11. So una, kikitaon naton anay an iya end behavior hining nga graph. Igdi-denote ta ito hin EB or end behavior. Kung kikitaon nimo, the degree is an even number and the sign of the leading coefficient is positive. So iton iya end behavior is that both sides or both ends of the graph are opening upwards. Ikaduha, kikitaon gihapon naton of course ang iya mga roots. So nag-a-assume kita nga you have already discussed papaano mabilngan iton roots in usa nga quartic or cubic polynomial or higher degree polynomials using rational roots theorem. Or if kaya mo hiya ma-factor out by grouping, then waray problema, mapahatag mo ang iya mga roots, pero mas convenient good ang rational roots theorem. So ang iya mga roots kung imo hiya kikitaon or ifa-factor out nimo an or igahatag nimo ang iya factored form, this polynomial is equal to p of x is equal to x plus 1 squared times x plus 3 times x minus 2. So kung igfa-factor out nimo ini, it magawas amo ini nga tutulo nga factors. Pero adiya nga x plus 1, there are two factors of x plus 1. I mean, this polynomial has two factors, which is x plus 1 times another x plus 1. So nagawas nga upat lagi hapon ang iya roots, simply because the degree is 4, and according to the fundamental theorem of algebra, if a polynomial has degree 4 is of degree 4, then it has exactly 4 roots. So kung kikitaon nimo, the roots are the following. In x plus 1 squared, meaning to say the root is negative 1 of multiplicity 2. Kaya ano nga multiplicity 2 ang negative 1? Kasi nakaduha hiya nag-exist, meaning to say there are two negative 1s as a root of this polynomial. Katima may daka gihapon negative 3 from here, ngan may daka dinhi positive 2 tikang dinhi. Katima pakabiling nimuhan iya mga roots, bibilngon naton ma-apply kita hingguti ay nga calculus, kay kasi kinahanglanon naton bilngon ang iya local extremum. Calculus iniya ginlileksyon, pero pwede naton iniya magamitan dinhi even if masaring kamo graphing polynomials is a math subject or math topic discussed in 4th year, pero masayon la pagbilinghan iya local extremum. Magamit ka lahing guti ay nga derivative or guti ay nga concept about derivative. Para ka makabilinghan local extremum, bibilngon na anay naton ang aton mga critical numbers. I-denote talahin letter C. Pero para mabilngan ini nga critical numbers, gagamitan tahin guti ay nga concept on derivative of a polynomial. diri gad ito makuri ipagbilinghit derivative hini nga polynomial bisan kon ito nga derivative nga topic adto na ito ha calculus. Diri ito makuri because the derivative of a polynomial is just actually the derivative get only the derivative of each term because nasiring the derivative of the sum is just equal to the sum of all its derivatives. Nakuha? So the derivative of x raised to 4, dito problema, imula bubuhaton, you just multiply the exponent by the coefficient. So 4 times 1 equals 4, copy x, and your exponent this time will be positive 3 because the rule in the power rule is that to get the derivative of a term, just multiply the exponent times the coefficient and then 1 less yung exponent niya. Next is 3x cubed becomes 3 times 3 is 9, x copy squared minus 6x minus 11, no more literal coefficient because the exponent of x is positive 1, so if you subtract 1 minus 1, the exponent this time is 0, and any number except 0 when raised to 0 is equal to 1. Thus, 11 times 1 is 11, or negative 11 times 1 is negative 11. And then negative 6, kay constant man hiya, the derivative of a constant is 0, so you don't need anymore to include that. Therefore, the derivative, by the way, this must be p prime of x. That is the symbol for the derivative or first order derivative. The derivative of a polynomial, p of x, is this time 4x cubed plus 9x squared minus 6x minus 11. So may daka na hini nga derivative of that polynomial. Gagamiton naton ini para mabilingan ta iton mga critical numbers. So to find the critical numbers, get the roots of the first order derivative. So aanon ta? So kung bibilhon ta roots, you have to of course equate the entire polynomial or first order derivative to 0. Kay amo ito karuyag sinyon ito nga bibilngon mo ang ira mga roots. So 0 or 4x cubed plus 9x squared minus 6x minus 11 is equal to 0. And then, magamit ka hin synthetic division or hin rational roots theorem kay cubic function na liwat ini, ano? So, gagamitan natin hin rational roots theorem. So, according to rational roots theorem, first, get the values of p or the factors of your constant. Since your constant is negative 11, the factors of negative 11 are as follows: positive and negative 1, positive and negative 11, because 11 is a prime number. And your q, dito nila isusurat, your q are the factors of your leading coefficient. Thus, we have positive negative 1, positive negative 2, and positive negative 4. Those are the factors of your leading coefficient. After obtaining your p's and q's, you are now ready to get the possible p over q's or the possible rational roots of this polynomial. Actually, bag polynomial lagi niya, polynomial lagi hiya, even if it is just the first derivative of your original polynomial. Okay? Kaya it magkakagawas hini nga mga roots, hini nga first order derivative han given polynomial will be our critical numbers. And critical numbers gagamiton naton para mabilngan taan mga extremum or the local maximum and local minimum. So, max or min. The local maximum or local minimum. So, what are our p over q's? So, p over q's, we could possibly have 1 over 1, 1 over 2, 1 over 4, 11 over 1, 11 over 2, and 11 over 4. So, anot aton mga possible rational roots hini nga first order derivative? May kita positive negative 1, positive negative 11, positive negative 1 half, positive negative 1/4, positive negative 11 halves, and positive negative 11 fourths. Damo ang aton posible nga maging rational roots hini nga first order derivative, pero dili ito nga tanan kay possible man lang. Nasiring in using the rational roots theorem, in testing which among these possible rational roots are the roots of a polynomial, you may test first the simplest, ang pinakasimple nga root or possible rational root. So, kitaon ta iton negative or positive 1. Kitaon ta itong positive 1. Use synthetic division. So, positive 1. What are the coefficients of your first order derivative? You have positive 4, positive 9, negative 6, katima negative 11. Kung kikitaon nimo, what will you get? Bring down 4. 4 times 1 is 4. 4 plus 9 is 13. 13 times 1 is 13. Negative 6 plus 13 is positive 7. 7 times 1 is 7. The remainder is 4 or negative 4. So, diri, ibig sabihin, positive 1, diri, root hininiya. Kitaon talot ito negative 1. We have 4, 9, negative 6, negative 11. Bring down 4. 4 times negative 1 is negative 4. 9 minus 4 is positive 5. 5 times negative 1 is negative 5. Negative 6 plus negative 5 is negative 11. And negative 11 times negative 1 is positive 11. And there you go. May nakita root nga negative 1. So, ibig sabihin, inihiya, this can be written as, since negative 1 is a root, from this solution nga nakakuha kan remainder nga 0, inihiya, pwede ta ma-factor out as x plus 1 times, to get this, we multiply x plus 1 times the reduced polynomial. These are the coefficients of your reduced polynomial. Since it is x cubed divided by a linear divisor, it quotient magkakaadahin x squared nga literal coefficient. Positive 5x minus 11. So, yan na. Ang ginawa, since negative 1 is a root of this first order derivative, may daka na x plus 1 times the reduced polynomial 4, 5, and negative 11. Mga coefficients inihan imo another factor for x squared plus 5x minus 11. Nang kung kikitaon nimo, ini naliwat, pwede nalot ini maghatag ha imuhin another roots. Kay this is quadratic, pero ayaw ka mo kahulop, basta quadratic na, you can now inhale and exhale. Kay kung quadratic, pwede ta makita, bangin pwede siya ma-factor out. So, kung pwede ma-factor out, may magkakagawas nga roots. Kung non-factorable quadratic trinomial man hiya, now, pwede natong gamitan tinatawag nga quadratic formula. Sige. Kung kikitaw nimo, ang first term is 4 and last term is negative 11 of this quadratic trinomial factor. 4 times negative 11 is negative 44. Tapos, waray pair of factors nga makakahimuhin negative 44 nga at the same time, inin mahatag hinsam nga positive 5 according to factoring of a quadratic trinomial. So, waray ta mahimo kundi magamit han quadratic formula para mabilngan taan mga roots ini. So, quadratic formula, ano to? X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Your a is your first coefficient in your quadratic, or your leading coefficient in your quadratic trinomial. Your b is 5 and your c is negative 11. Siyempre, isa-substitute ito natin. We have x is equal to, your b is positive 5, so may daka negative 5 plus or minus square root of, your b is positive 5, square that, you will get 25. And then 4 times a is 4 times 4, 16 times 11 is negative 11 rather is negative 176. Takay negative 176 minus man ini. So magkakaada kahim plus 176 all over 2 times a. Your a is 4, may ada ka positive 8. So may daka negative 5 plus or minus is square root of 25 plus 176 over 8. Katima, kung ipapadayon ito natin, x is now equal to negative 5 plus or minus square root of 176 plus 25 is equal to 201 divided by 8. and x is equal to negative 5 plus or minus, it's square root of 201, pwede mo gamitan ng calculator. Katima, pwede ka maghatag hit iya rounded value la. Bisan la ko to lahat 3 decimal digits. So the square root of 201 is 14.177. Or syempre, tututuan mo yung tama nga pagbasa ang kabataan in decimal. Papaano ang tama nga pagbasa hit 14.177? That will be 14 and 177 thousandths. Okay? Katima ito, since this is plus or minus, ibig sabihin lang yan na meron kang dalawang possible na mga values. So what do we have? We have x. X sub 1 is equal to negative 5 plus 14.177 over 8. X sub 1 is equal to, if you are going to add, if you're going to combine negative 5 and positive 14.177, and then i-divide mo ito by 8, it magawas nga answer is positive 1.15. And usaliwat, you have negative 5 minus 14.177 divided by 8, it magawas ito kay negative 2.40. So yan na, may dana kita duha nga roots inihiya or zeros ito hira hini nga first order derivative han imo polynomial. Takay kanina, when we use synthetic division, ginawas gihapon negative 1 nga root hadto nga first order derivative. So nagawas nga tutulo na yan ang aton roots. We have negative 1, we have 1.15 and negative 2.40. Inira nga tulo, these are our critical numbers. So ano to? May daka negative 1, may daka 1.15, and may daka negative 2.40. So ito amo ito ang aton mga critical numbers. So pagkabiling naton ang critical numbers, bibilngon tayo na ang mga local extremum. Paano? Isa-substitute talaan aton tutulong nga critical numbers. Since nasa rin kita nga c sub 1, ano ton siya nga critical number? Negative 1 ano? Of course, bilngon mo nga ni iton iya p of negative 1. I-substitute ang negative 1 hini nga polynomial, the original polynomial, it magawas kay 0. Why 0? Because kay imo polynomial, negative 1 is also a root. It is also a root of your polynomial. Okay? Katima, so ini magkakaada kita, therefore hin coordinates nga negative 1, 0. Han imo liwat c sub 2, which is 1.15, bilngon mo nga ni ang p of 1.15, i-substitute mo ini ditohan imo given nga polynomial, it magawas nga value is equal to negative 16.31. Negative 16.31. So ibig sabihin may dakita coordinates nga 1.15 katima negative 16.31. Ang imuliwat third nga critical number, so amo dit aton ikaduha nga coordinates han aton critical numbers. So either or any of the three, kung bilngon ta anay ang critical number 3, which is negative 2.4 or 2.40, tas bilngon mo nga ni ang value han p of negative 2.40, it magawas nga answer kay negative 5.17. Negative 5.17. So, nagawas na may dakita coordinates nga negative 2.40 and negative 5.17. So, ini nga tutulo nga mga coordinates. These are the coordinates of your local extremum. Your local extremum. It could either be maximum hiya or minimum hiya. So, kahuman nito, kung nabilngan na naton ang mga critical ang mga local extremum, ready na kita paghimuhin graph. Okay? Ready na kita paghimuhin graph. So, siyahan, since inihiya mga negative 16 aditon hiya kuan, aditon hiya ubos hiton y-axis. So, pwede kita maghimo hin Cartesian plane nga nahatag hin enough space para ha imo negative value sa imo y. So, pwede ta himuan nga sugad. San lakotob nga da. Of course, ay paghingalimti, these are lines. You have to put arrowheads on both sides of the lines ng imo x and y axis. So, yan na. Pwede kita magkuan, butanghin calibration nga by 2 sa imo y axis. So, 2, 4, 6, 8, 10, 12, 14, 16, 18. So, dito negative 16, negative 2, 4, 6, 8, 10. Dito mo negative 10. So, i-calibration hini is by 2s. Pero, ang aton liwat x-axis, pwede aton calibrations by 1s la. Sige. You have negative 1 and negative 2, negative 3. Tapos, didilo takaluyo, may daka positive 1, positive 2, and positive 3. Okay. So, yan na. First feature, the end behavior are both up on both sides. So, it katapusan, pero may maso ganito. Okay. Second, ikaduha, ang aton mga roots kay negative 1, negative 3, and positive 2. So, negative 1, hain ito. Ini, negative 1. And then, you have positive 2 and negative 3. Oh, may dakita sugad. Ito, amo ito't mga roots naton ang aton mga x-intercepts. Katima ang aton y-intercept. Ano yan ang aton y-intercept? Given our polynomial, our y-intercept is negative 6y. If you substitute all values of x with zeros, all x's with 0, everything of this will be equal to 0, leaving negative 6 behind. So, negative 6 itong aton y-intercept. Hain it negative 6. This is 2, 4, 6. Dida? Negative 6. And then, ano ang aton mga critical, ang aton mga local extremums? Ang aton local extremum, you have negative 1, 0. Adi na itong didi. And then, you have positive 1.15 somewhere here. Kay kung didabot ka 1.5, somewhere here 1.15. Baga sobrahay lagote ha, 1. And then, negative 16.31 itong iya. Ordinate. Dito ha, ubos. So, 0.5 man yan 0.31 mga somewhere here. So, kung 1.15, tapos 16.31 somewhere here. That will be one of our local extremums. Ang ikaduha is, ang ikatulo is negative 2.4 ang aton x, which is here. Kung negative 2.5 adabot nga, so 2.4 somewhere here lang. And then negative 5.17 ang aton y. So kung this is negative 6, of course, kung negative 6 ini, ambot nga dida, negative 5. So kung negative 5.17, sobra hilaga may have negative 5. So kung negative 5, negative 5.17, ani din Tapos negative 2.4 somewhere here. So, may dakita. So, ganito. So, naiplat na naton ang aton tutulo nga mga critical numbers. And now, since maram kita nga na-open hiya upward, both ends open upward, i-connect na naton using smooth curves. So, ano na? Smooth curves. Na nakita naton ang multiplicity negative 1, which is 2 even. Now, itong multiplicity, for sure, gin-discuss iniha ayo niyo teacher, if the multiplicity of a root is even, meaning to say, the graph mag-approach ito nga imo root nga negative 1, it will only bounce or matouch lahiya. Kung tikang haubos, pag abot nga ng negative 1, ma-bounce back, going down. Kung tikang haigbaw, pag abot ng negative 1, ma-bounce up. Okay? Kung negative 1. But here, in our graph, since both ends are opening upward, so ibig sabihin, tikang didihiya. Matarahan negative 3, pagkada kay extremum hiya, ibig sabihin ma-bounce back hiya. Tapos pagkadihan negative 1, since multiplicity kay even ha negative 1, the multiplicity is even, so ma-bounce back hiya. Pag-approach sa negative 1, ma-bounce back hiya. And then, matara hiya y-intercept kay y-intercept hiya. Matara din hiya y-intercept. And then madiretso nga diha imo usa pa ka local extremum. So kay local extremum man hiya, so ma-bounce back hiya. And then continue ti paigbaw until makahimo ka na an imo graph. So there you go, your graph of your polynomial function p of x. This is polynomial function p of x is equal to x raised to 4 plus 3x cubed minus 3x squared minus 11x minus 6. This is our graph. Kung gusto mo hiya kitaon kung tama or mali ang aton kahimuhan graph, wala hito problema. Kung may ada ka WinPlot, WinPlot is a software ha imo computer nga pwede mo makita or pwede ka mag-graph. Baga nga niyang graphics calculator. So kikitaon naton hiya WinPlot kung tama ito aton graph. Alright, are you ready? Kung tama itong aton graph, so kitaon naton. This is the graph of, alright, so that is the graph in my computer. Hiya natarahan negative 3, na bounce back hiya negative 1, tas dida hiya local extremum nga negative 2.4, kama negative 5.17, napas hiya negative 6 nga y-intercept, kadiha negative 16.3, and then go up again ha positive 2. So if kikitaon nimo, ito ang graph akon computer. Ang aton graph nga ginhimo using our method, our own method. So that's all. Thank you.